So in this video, we're going to talk about Pearson's product moment correlation coefficient, or Pearson's correlation. Okay, so let's have an example of two variables, which are age and sleep duration. So the data are given, and we want to answer this question: is there a significant relationship between age and sleep duration? So when it comes to test of relationship between two variables which are continuous variables, we use the Pearson's R, or the Pearson's product moment correlation coefficient. So let's solve this. Is to write the given vertically in column, so just like this, and then we're gonna label the variables with x and y. So we'll name the variable age as x and the sleep duration as y. So even if you interchange the two, you want sleep duration to be the y, to be the x, and the age will be y. It's going to be the same result. So that is interchangeable. So the next step is to add one column, which is we label it as x times y, or xy. So basically it means you multiply the x and y columns. So we have 10 times 8, that's 80. 22 times 6, that's 132. 15 times 6, that's 90. 36 times 5, that's 180. 42 times 4, that's 168. And 50 times 7 is 350. The next step is to add another column. It's labeled as x squared, or the square of x. So it means we're going to take the square of the data in column x. So we have 10 squared is 100. So by the way, square means you multiply it by itself. So 10 times 10 is 100. So 22 squared, that's 484. 15 squared is 225. And 36 squared is 1296. 42 squared is 1764. And 50 squared is 2500. Next step is to add the last column, the square of y. So I'm going to square all the data in column y. We have 8 squared, that's 64. 6 squared is 36. Another 6 squared is 36. 5 squared is 25. 4 squared is 16. And 7 squared is 49. Okay, so those are the columns that we needed to be added in our table. And then we're going to take the total for each column. So the total is denoted with the Greek letter summation, or sigma symbol. It means sum of the column x. So let's add. So 10 plus 22 plus 15 plus 36 plus 42 plus 50, you'll get a total of 175. Then get the total for y, column y, which is, we call it the sum of y. So it's 36. The sum of xy, it's 1000. The sum of x squared, it's 6369. And the sum of y squared, it's 226. Now after taking all those sum, then we're going to start using the formula. So here's the formula for the Pearson's R. So you have R. Okay, so the Pearson's correlation is denoted with the letter R as the correlation. Here's the formula to find the R. Okay, so we're gonna take it one by one. We're gonna start with the N. So N is the number of samples, or the number of pairs in our given data. So there are 6 pairs, so we're gonna replace this N with 6. Next is the sum of xy. So sum of xy is this. So we have solved it and it's 1000. So let's replace it in our formula. Next is the sum of x. So the sum of x is this. And in our formula, there are two sum of x, so let's replace both. Next, we're going to replace the sum of y. So there are also two sum of y's in our formula. So we're going to use this data. It's the total of y, which is 36. So let's put it in our formula. Next is the sum of x squared, which is this. It's 6,369. So let's put it in our formula. And then the sum of y squared. So which is this, it's 226. All right, so we have a replace or substitute all the values in our formula, and let's start computing. So we're gonna start computing with 6 times 1000. So that's 6,000. Next is 175 times 36. So that's 6,300. And then we are going to subtract the top. 6,000 minus 6,300. That will give you negative 300. And then we're going to multiply 6 times 6,369. So we have 38,214. Next is the square of 175. That's 30,625. Then 6 times 226. So that's 1,356. Then square of 36. It's 1,296. Okay, so next is we're going to calculate the first pair at the bottom, 38,214 minus 30,625. So that's the difference of 7,589. Then the other pair, 1,356 minus 1,296. That's a difference of 60. Then let's multiply the two numbers at the bottom. 60 times 7,589. So that's 455,340. So next is we're going to take the square root. So square root of 455,340. So that's approximately 674.79. So as you can see, we changed the equal sign to a symbol of approximately equal to because we rounded off. So it's not anymore the exact answer, but we rounded off to 2 decimal places. Next is we divided negative 300 divided by the decimal. So we have a correlation of negative 0.44. So what does it mean by this? So let's pull up our table of interpretation. So it falls under the moderately strong relationship. It's 0.44 and it's negative. So it means it's negatively moderate relationship. But we are not yet sure because we are going to test the significance. If it's significant, then this is true that it's negatively moderate relationship between age and sleep duration. But if it's not significant, then it is this result of 0.44 is just nothing but equal to 0. So let's test the significance of this using the formula for t, r squared of n minus 2 all over 1 minus r squared. So let's replace n with the number of pairs, which is 6. So 6 minus 2. For a while, the r, we're going to replace the r with the value negative 0.44. And then that's the time we start computing. So 6 minus 2 is 4. And then take the square root of negative 0.44, that's 0.19. Then subtract 1 minus 0.19, 0.81. Then divide 4 divides 0.81, so that's 9.34. Then take the square root of 9.34, so approximately equal to 2.22. Then multiply negative 0.44 by 2.22, so that's t approximately equal to negative 0.9768. So it will be now 4 decimal places if it's the t, or the test of significance value. Next step is to find the degrees of freedom. So we need this degrees of freedom to know the test critical. So formula for finding the degrees of freedom of a Pearson's R is n minus 2. So our n, or the number of samples, that's 6. So 6 minus 2 is 4. So let's pull up our t table. So the t table, the left side, you'll see the df, or the degrees of freedom, and it's here, it's 4. And the alpha, or the level of significance, is always 5% unless it is specified. So it's here, it's 0.05. And let's look at the value of the test critical. It's 2.776. So this critical value will be your basis for comparing with the t value. So if the absolute value, if the t value, absolute value, so that means you just simply ignore the negative sign, so it's 0.9768, and compare it with the t critical. So if it's lesser, since it's lesser than the critical value, then the result is not significant. So for it to be significant, the absolute value of the t should be bigger than the critical value. So since it's not significant, then we can conclude that there is no significant relationship between age and sleep duration.